Hello, our most valued student. My name is Confident. Welcome to our 24-minute lesson. This lesson is a discussion of the mathematics N3 question paper, which was written in November 2019. So we are going to look at the memo discussion, or we are going to look at some suggested solutions of the paper, which was written, as I said, in November 2019. The actual date was on the 20th of November, and as I said, this is mathematics N3 question paper. It was written in the morning by X, they mean in the morning, and it is a 3-hour paper. As they said, note that programmable calculators are not allowed. The most common calculator that you can use is your scientific Casio or your Sharp calculator. Now let us quickly look at some of the most important instructions that you need to be aware of. As I said, this is a 3-hour paper. It is out of 100 marks. It is the paper from the Department of Higher Education and Training. Usually we call it the DHET. And the instructions read as follows. It says you need to answer all the questions. You need to read all questions carefully. You must number the answers according to the numbering system used in this question paper, meaning do not come with your own numbering system. You must follow the sequence. And then says questions may be answered in any order, but do not separate the subsections. So it means you have a liberty, or you are allowed maybe to start with question number 5. But when you choose to start with question number 5, ensure that you answer everything that is concerning question number 5. Don't mix, maybe for example, say question 5.1 and you jump to question 1.2. Such subsections cannot be mixed and you might lose some marks if you combine these. So whatever question you choose to start by answering, remember you need to answer the whole of that question, that is the subsections that are involved in that question. Instruction number 5, it says show all calculations and intermediate steps. As you can see, they did even put the all calculations, because most of the time sometimes students forget, or they write their calculations in the question paper and they forget to take those calculations and include them in their answer script. And the next point says all graph work must be done in the answer book. No graph paper is needed, so you must do all your graph work in the same answer book that you are given. You'll never be provided with a graph paper. Remember, you need to sketch some of your diagrams, so you don't need to draw accurately. Instruction number 7 says all final answers must be accurately approximated to 3 decimal places. So remember to leave your final answer up to 3 decimal places, and diagrams are not drawn to scale, and so don't use a ruler to try to measure those diagrams. As well as you need to write neatly and legible, meaning if you do not have a neat handwriting, or if you write clumsy, they are going to penalize you some marks. Now let us start with our first question. This was question number 1. And question number 1.1, it says factorize the following as far as possible in prime factors. So the key word first is to factorize. The second one says as far as possible, and you must leave your answer in prime factors. Now let us start by analyzing the question. You are given 16x squared plus 4y minus y squared minus 4. Now the way they brought this question paper, this question 1.1, it was a bit tricky, but let us start by trying maybe to collect 16x squared minus y squared plus 4y minus 4. So I just did some rearrangement. I put the 16x squared closer to the minus y squared. Why did I do that? this is my difference of two squares, whereby I have my 4 squared x squared minus y squared plus 4y minus 4. So when I was bringing these together, it is a difference of two squares, whereby I have got my two brackets. For the difference of two squares, I have my 4x minus y, and I have my 4x plus y. So this is a difference of two squares. Now in the last two, you can see that 4 is common, so I can say plus 4, and then I'll have my y minus 1. So this is as far as this factorizing can happen. Maybe let me try another one or another method. I'm given, in this case, it's 16 x squared plus 4y minus y squared minus 4. So if I can come with another method, maybe in this case I can choose to group 16x squared minus 4 plus 4y minus y squared. So I can choose to group them like that. This is also the first two. It is a difference of two squares, whereby I'm having 4 squared x squared. Actually, before that, I can choose to take out 4, as 4 is common. So I'll have 4x squared minus 1, and then I can have plus in the second 2, y is common, so I can choose to say plus y, and then I'll have 4 minus y. So this is what I'm having. But now in the first bracket, this is a difference of two squares, whereby I'll have 4 and 2 squared x squared. Remember, 1 is same as minus 1 squared plus y, 4 minus y. So then I can continue now, coming up with my two brackets. As in the difference of two squares, I have 2x minus 1, I have 2x plus 1, and then I have plus y, 4 minus y. So this is as far as I can factorize that. So it was kind of a difficult question to go about, but I suppose, as I say, this is a discussion or suggested solutions, depending on how the examiner was approaching it. I think both answers, even if you wrote the first one, I suppose you have factorized it as far as possible. Or if you went through the route of the second one, also you would have factorized it as far as possible. I will give both candidates the full marks, which is 4 marks in this case. Let us move on. Question 1.2, it says, determine the value of p if f of x, which is given, and in that f of x there is p there, gives a remainder, very important, a remainder of 6 when divided by 2x plus 1. So there are key things that are important. Now you need to get 5 marks out of this. I will come with one of the quickest ways in which you can approach this. So the first quicker way for you to do is for you to focus on this remainder of 2x plus 1. So you equate 2x plus 1, you equate it to 0, and then what you do is you solve for x. The 1 jumps to the other side, so you're going to have 2x is equal to negative 1. Then you divide both sides by 2, then you're going to have x is equal to negative half. They will give you a mark for this step. So you are now having your x is equal to negative half. Then the next thing that you need to do is you need then to have your f of minus 1 over 2 is equal to. So now if you go to your question that is given, remember we are given our f of x. If I can write it on top, my f of x is equal to 2x squared plus px minus 5. So now with this f of x, where there is x, now I have put a negative half, which is equal to 2 minus 1 over 2 squared plus p minus 1 over 2 minus 5. So I can simplify this further. It will be 2, or you can use your calculator straight away. This is 1 over 4 minus 1 over 2p minus 5. And then if you look at that, you will have, in this case, 1 over 2 minus 1 over 2 minus 5. So this is what it simplifies. But there is something interesting. They say this gives a remainder of 6. So they are trying to say, if you say f of negative half, you are going to get a remainder of 6. So that's what they're trying to say, meaning you can rewrite this as 1 over 2 minus 1 over 2p minus 5. You then equate it to 6. So that's what basically they're trying to say. Now the next thing that you need to do is for you to solve for p. In actual fact, you can collect your like terms, whereby you are going to have minus 1 over p. All the numbers, the half will jump and the 5 will join the 6. So you will have a 6 plus 5 minus 1 over 2. So now you can use your calculator, which is 6 plus 5 minus a half. You've got 21 over 2. So now you've got minus 1 over 2p is equal to 21 over 2. Then the next thing is, you can see that 2 is common, so you can choose to cancel the 2 at the bottom, meaning minus p is equal to 21. You divide by negative 1 on both sides. You are given that p is equal to negative 21. So the question is, determine the value of p. So we have managed now to determine the value of p, and the value of p in this case is equal to negative 21. So this is the approach that you could have used. And there is another approach which I don't advise, but it can actually be one way of approaching it. Remember, it says determine the value of p if f of x is equal to that gives a remainder of 6 when divided by 2x plus 1. Maybe if I can rule off and use a different pen. Now, one other approach that you can use is the long division approach. Now, the long division approach, what you'll be having in this case, you'll be having, if I can just take a little bit of space, I have my f of x there. So what you'll be having in your long division, you'll be having that. Remember, you are dividing by 2x plus 1. So you have your 2x plus 1 there, and your f of x, which is 2x squared plus px minus 5. So let me use now enough space. So this is what you'll be given. Now you can do, as I said, what I call the long division, and you need obviously to go to my previous lessons or any other lesson where you practice the long division method using this process. So what do? I'll be working a little bit on the other side. It's 2x into 2x squared. So I'm saying 2x squared divided by 2x. Now the 2 cancels the x, one of them will remain, so I will have x on top. And then when I have x on top, now I multiply x by both 2x plus 1. So if I multiply, I'll say x times 2x, which is 2x squared, and then x times 1, which is plus x. After that, I roll off and I subtract. So 2x squared minus 2x squared, I get a 0, and px minus x, I'm going to get a px minus x, and then I'm going to bring down the negative 5. Now something interesting, you can see that x is common, so I can move on to say x is common. I have got p minus 1 minus a 5, and then I move on to say 2x into x p minus 1. In this case, I will have, it's a x p minus 1 over 2x. You can see that the x will cancel, but you'll remain with p minus 1 over 2. So on top, I'm going to have, in this case, it is a plus p minus 1 over 2. That's what I'm having. And then with that, I'm going to multiply like I did first. P minus 1 over 2 times 2x. I'm going to have x p minus 1, and that times that, I'm going to have plus p minus 1 over 2. I subtract, I roll off, that will give me a 0, and then I will have minus 5. I will have a minus 5 and minus p minus 1 over 2. Now when you have done that, you can see that normal x is remaining. In this case, it means you have fully factorized. But something is interesting is then this becomes your remainder. So when the question says, if I go back to the question says determine the value of p if that gives a remainder of 6 when divided by that. So they are telling us, in actual fact, we were supposed to get a 6 here. That remainder is equal to 6. So we're supposed to get a remainder of 6, but the remainder, remember, it is in terms of p. So for me to find my remainder, I can then say minus 5 minus p minus 1 over 2 is equal to 6, and then I can make 5 join 6, so I'll have minus p minus 1 over 2 is equal to 6 plus 5, which this is 11, minus p minus 1 over 2. So for me to solve for that, p I multiply by 2 on both sides so that I can cancel that. Then I'll have minus in brackets p minus 1 is equal to 22, which means I can divide by negative 1 on both sides, and I will have a bit of space. I will have that p minus 1 is equal to negative 22, and then I'll have p is negative 22 plus 1. Why? because the negative 1 did cross the sign, and then I'll have p is equal to negative 21. So you can see now that my p is negative 21, and negative 21, if I'm not mistaken, it is the same answer. If I can look for the previous answer of p, you can see that we also got a p of negative 21. So as I'm saying, these are two approaches. The second one involves a bit of algebra. If you are not strong with your algebra, I will not suggest it, because you can see that you need to be very careful with your long division as well with your signs. If you make a mistake, then you are going to get everything wrong. I will always suggest the first method, and then you can use the second one maybe to prove that your answer is correct. Now let us move on to question 1.3. Now question 1.3 says you need to simplify the following expression. So that is the aim. You need to simplify, and it's 5 marks, and you can see it now gives you a total of 14, meaning this was the end of question 1. It ended with 1.3. Now how do you approach this kind of a problem? The best thing that I always suggest students to do is do not approach it as one thing, but you need to do it in parts, and then you pull everything together so that you can write your final answer. So let us start with the first one. Let us start with the numerator there. I'm having m squared plus m minus 2. Now I need to factorize this, and the best method of factorizing that I use is called the product sum method. In the product sum method, what I do is I take, there is a 1 there, I take the first and the last, I multiply them, they give me what is called the product, and then the center one, it gives me the sum, which is s for the sum. So if I multiply 1m squared times minus 2, I'm going to get a product of minus 2m squared, and my sum is the number that I see, which is plus m. Now I'm looking for factors, and the factors I'm looking for are the factors of 2, and the factors of 2, it's 1 times 2. Now when I've got these factors, now what I need to do is I need to multiply these factors 1 and 2, and when I multiply them, I must get a negative product, so which means one of them needs to be negative. They cannot be negative, both of them, because if I multiply a negative 1 times a negative 1, I will get a positive 2. But now my product is negative, meaning either 1 is negative or 2 is positive. But my decider is the sum, and the sum is telling me that my sum is positive, meaning when I add these two numbers, I must get a positive 1m. So it means the bigger number, 1 and 2 here, the bigger number is the one that must be positive. So I'll have a positive 2 and a negative 1. So now when I write my final, I'll have my m squared. Now it's plus 2m minus 1m minus 2. You can see where there is a positive m, now I have replaced that with 2m minus 1. Now, when I've done that, I factorize by grouping. Take the first 2 and the last 2. I will have my m, which is m plus 2 minus 1 and m plus 2. So I have my m plus 2 and my m minus 1. There are many ways you can factorize, but this is the simplest or the best way that I always suggest to students to say, if you are factorizing, try to use the product sum method. Now moving on, we can also factorize the bottom, which is the denominator of that fraction, and I've got 3m squared minus 2m minus 1. If I factorize that using the product sum method, Similarly, I multiply the first and the last, it's my product, and my center is my sum. So what's my product? It is minus 3m squared, because it's 3m squared times negative 1, and my sum is minus 2m, and my factors, the factors of 3 is 1 times 3. And if I come to look now at the signs, in this case, I need to, the product is negative, means one of the factors must be negative, and the sum is negative, means the bigger number must be negative and the smaller number must be positive. So which means I'm going to have 3m squared minus 3m plus 1m minus 1. So I do grouping again. In this case, you factorize by grouping. Take the first two and the last two. I will have my 3m being common, and I have my m minus 1. As you can see, plus 1, I need to maintain the same brackets. The brackets must always match, which is m minus 1. And outside the brackets, I've got 3m. You also put it in brackets, plus 1. Whatever is outside the brackets is making the last bracket. So you have done that. Again, as you can see, this was my product sum. If I can get more space here. So now, moving on, in this case, we are going to factorize 2m squared plus m minus 6. I'm going to use the product sum again. Now when I'm using the product sum, multiply the first and the last, you multiply them, and the sum is the one in the center. So my product in this case is equal to minus 2 times 6 is negative 12m squared, and my sum is equal to plus 1m. So in this case, I'm looking for the factors of 12. Now factors of 12 is 1 times 12 is 2 times 6 is 3 times 4 is 4 times 3. So whenever I'm repeating the factors, it means these I have exhausted all of my factors. Now I'm looking for a product. When I multiply them, I get a negative 12. So it means any of these pairs will always give me a negative 12 when provided one of them is negative. But the decider is always the sum. I must get a positive 1. So you can see that in these, the first one will not give me a 1, because 1 and 12 cannot give me a sum of 1. Even if I add 2 and 6, I cannot get a 1, but the last one is where the answer is. 3 and 4 can give me a 1, but remember, when one of them has to be negative and one of them has to be positive, the sum is positive. So I've got a positive 4 and a negative 3. So when I rewrite, it will be 2m squared plus m. In this case, I don't need to write the m again. Remember, the m is now represented by plus 4m minus 3m, and is minus 6. It doesn't matter how you write these factors. You can start with negative 3 or positive 4, as long as you're going to write them in any order. It doesn't matter. So you do grouping. In this case, you take your first two and your last two. So it will become, what is common there is 2m, and I'll have my m plus 2. My second bracket also must be the same. As you can see, a negative is common, and 3 is common between 3 and 6, which is m plus 2. So I will have what is in the bracket is m plus 2, and outside the bracket I have got 2m minus 3. So again, we have managed to factorize that, and we can now look at the last part. If we are to factorize the last part, and the last part that I'm given in this case, I'm given, if I can do that, it's 9m squared plus 6m plus 1. And again, my product is the first and the last one, which is my product. My sum is that. So my P is equal to positive 9m squared. My S is equal to positive 6m. So now I'm looking for the factors of 9, which is 1 times 9, and the next one is 3 times 3. As I said, you need to always look at these factors. There's always going to be one that is correct. You'll never have a situation whereby maybe two factors or two pairs are correct. You always have one. For example, in this one, when we multiply, we must get a 9 in which both sides is satisfied. All of them must be positive, but the decider is the sum. It says the sum must be 6. As you can see, we cannot get a 6. We cannot add 1 and 9 to get a 6, but we can add 3 plus 3 to get a 6. Remember, the sum is positive, meaning both must be positive. So if I rewrite that, I will have this as 9m squared plus 3m plus 3m plus 1. And then if I do my factorizing by grouping, take the first two and the last two, I will have 3m being common. With 3m being common, I will have 3m plus 1. And already, if you look at this second group, it's already 3m plus 1. So you take out a 1, which won't change anything, and you'll have 3m plus 1. And then if you simplify that, you are going to have 3m in brackets is 3m plus 1, and outside the brackets you can see it's 3m plus 1. So you can repeat that also as 3m plus 1. So this you have managed to factorize. If I can then bring all this together, this is what I'm going to do. If I can use my different pen, this then becomes, if I can have that, this then becomes, you can see, if I can now analyze that, we have a division sign there. So I'm going to change that division sign into a multiplication sign. So the moment I put a times, the top will go below and the bottom will go on top. So remember that. And actually I didn't finish the last one. I can erase. I've got the last one, which is 4m minus 12. If I can also factorize that using another pen, if I can do that, 4m minus 12 is 4 is common, and I'll have m minus 3. So this one is not a problem. That's why you can always actually leave it out and factorize it directly from that. So now if I can write all this together, I'm going to have the first one. Remember, it became m plus 2, and then m minus 1, and then divided by the second one, which is 3m squared minus 2m minus 1. It became m minus 1, and it was multiplied by 3m plus 1. And then, as I said, I'm going to put a multiplication sign so that the 9m squared plus 6m plus 1 goes on top. But that 9m squared, if I can divide, and the 2m squared plus m minus 6, which was on top, goes below, which is the one in white, and we got that m plus 2. Now it has gone below as m plus 2 and 2m minus 3. And if I can check my factorized, it was 3m plus 1. Remember the 9m squared plus 9m squared plus 6m plus 1 became 3m plus 1, 3m plus 1. So I'm going to have it as here 3m plus 1 and 3m plus 1. And then I will multiply that by 4m minus 12. We said it became 4, which is m minus 3 all over 3m plus 1. So this is basically the simplified or the factorized version of the first fraction. Then what you need to do, then you need to cancel out whatsoever is common. So you can see m minus 1 will go. I need to close that bracket. And with m minus 1 gone, I can choose another one, 3m plus 1 and 3m plus 1. 3m plus 1 and 3m plus 1 is gone. And then I've got m plus 2 and I've got m plus 2, also that is gone. And then if I can look at the top, I've got 4m minus 3 and 2, and the bottom I can move on. At the top, remember this is 1, this becomes 1 1 1 1 1 1. So I've got a 4 at the top, m minus 3 all over, and then at the bottom I've got a 2m minus 3. So in actual fact, this if we can't factorize this further, then this becomes the final answer. So the final answer then becomes 4 into m minus 3 over 2m minus 3. But now sometimes I always ask myself, how do I know that my answer is correct? Now, to know that your answer is correct, you can give it this kind of a trial. What I do is I take my calculator and I usually choose any number. Remember, this is you're just checking if your answer is correct. So I'll write proof. Now on my proof, I can choose maybe to say let x be equal to, let's say maybe 15 in this case, not x, actually it's m. So you can say let m be equal to, let's choose just a simple number. Let m be equal to maybe 7. So don't choose a number which will give the fraction a 0 at the bottom, because you are going to get an error. So when your calculator gives you an error, try another different number until you get the answer. So let's say m is equal to 7. So now with that, I take my calculator, and what I do is where there is m, I put a 7. So for example, this is 7 squared plus 7 minus 2 all over 3 into m, remember, is 7 squared minus 2, 7 minus 1. So you see what I'm doing? I'm doing that because I said let my m be 7. I type it as it is, divided by, it must be a fraction, 2 into 7 squared plus 7 minus 6 all over 9 into 7 squared plus 6 into 7 plus 1 times again 4 into 7 minus 12 over 3 into 7 plus 1. So this is what I do wherever there was an m, I was putting a 7, and then I get my answer. You can see it says my answer is 11 over 16. So with that, I get my final answer as 11 over 16. Was it 16 over 11 or 11 over 16? I forgot that. Now I take again my calculator. Now I go to my final answer, which is the one that I have as 4 into m minus 3 over 2m minus 3. I also put a 7 to see if I'm getting the same answer. This is 7 minus 3 over 2 into 7 minus 3. So you see, I put 7 in the first one and I'm putting 7 in the last one. If I'm getting the same answer, actually it was 16 over 11, not 11 over 16. If I'm getting the same answer, it means I have managed to factorize and reduce this thing into its simplest form. So it was 16 over 11. You can see this here gives me 16 over 11 when m is equal to 7. Even here I'm getting 16 over 11 when m is equal to 7. So if this matches with that, it means I have managed to factorize and I have got more assurance that my answer was correct in its simplest forms. Now we have come to the end of our lesson. As I said, these are approaches one can use whenever they are revising for their end of year exams, whenever you'll be earmarking to write your mathematics N3 paper. So you can use these as a great way of doing your revisions, and believing me, it will go a long way in ensuring that you get your distinctions in that paper. We have come to the end of our lesson. Thank you.